because of, because of the fact that Zoom actually went back to its policy, which is to to limit the meetings to 40 minutes. After 40 minutes, Zoom kicks you out, and then you have to come back. That was a policy, I think, unless you have like some type of business account, or, where you have to pay some premium stuff, monthly premium. That was the case until COVID. When COVID came, so I think, so let me talk to people who are in Zoom. So please, can you go to Teams, please? The class is done in Teams, not in Zoom. When you go to Brightspace, or I think your email, you receive an email for the link, the Zoom, the Teams. Okay.
Oh, okay.
All right. I'm sorry about that, but we had no choice.
All right.
Okay. All right. So, and then probably Zoom said, okay, to bring their contribution to the worldwide effort. They said, okay, for the education, we're gonna remove the limit of the meetings. All right. So everybody, can you go to Teams, please? Can you go to Teams? We are, the class is done in Teams, not in Zoom. I'm just connecting in Zoom with my cell phone for today. Just to let you know, you have to go to Teams, okay? The link is on Brightspace. All right, thank you. All right, so now I think that they say, okay, after maybe a year or 2 years, they coming back to the to the old policy. But it is the same, we still Zoom or Teams, it is the same thing. I did grade your test, right? Okay, I sent you back the graded papers. So now it's like, some people did good and some people not good at all, okay? So, but some people did good. So it's like very hard to judge, Sometimes, you have this, right? Some people did really good and then other people do not do that. So, it's very hard to say, exactly where is the middle stuff, okay? So what I would advise people who didn't do good is for the next test, you see, the test is very different from the quiz, by the way. And, it's always, amazing if you know how to do something in a quiz, you should know how to do it in a test, right? And the conclusion about it is maybe, the quiz like is a take-home quiz, stuff like that. So maybe we didn't, etc. But the test is, is a proctor test. So that is different. So for the next test, please do everything you can to prepare it, good. I have office hours. I gave you, the link for tutoring at any time. You have tutoring at any time for 083. If you go, CCBC professor will actually tutor you for 1 hour, you see, and then you can go to the next section for another hour, etc., etc. I really advise people to do that because, the test, they are 15% and they are, they need some preparation, okay? All right, so now today we're gonna go, let me see, okay, I'm new in Teams, but I think I will be able to do it. So the window is this one. Okay, so everybody is able to see my window right here?
Yes.
Yes.
Okay. All right,
Yes.
so we're gonna continue on. Last time we did square root. If you remember, last time, for instance, we said square root of, square root of 98. How to simplify this square root of 98? Okay. Can somebody suggest to me what to do? Hey, Teresa, can you go to Teams, please? Can you hear me?
Yes, I'll do that now. Thank you.
Okay, try to go to Teams because the session is done in Teams, please.
Okay.
All right.
Thank you.
You're welcome. So right here, can somebody tell me what to do to simplify square root of 98? You know, it's going to involve some arithmetics. You remember last time we said you have to break down 98 as a product of two numbers, and we want one of them, at least one of them, to be a perfect square, right? What numbers come to your mind? Can somebody tell me? No? No one has an answer?
49 and 2.
Exactly, 49 and 2, right? You see? So the squares of 98 can be broken down into squares of 49 times 2, right? And since this is like a square root, then we have a split, right? We have since it is a product, so we can split. When you split, the 49 comes out. When this comes out, it becomes what? What is the square of 49?
7.
7 root of 2. You see, this is how we simplify. Okay, since okay, let me make sure before we move on, let me make sure that we know how to do that, right? Okay, so let me say simplify square root of 50, square root of 200. All right, and then 7 square root of 32.
So
Go ahead, everybody.
I have a
Yes?
question.
Yes,
So
go ahead.
the number outside of the square root sign is the number we should see that is going to divide by itself, and then the number inside the square root sign is that number that we just divided by itself multiplied by that number under the square root sign.
Hold on. So, can you repeat the question, please? So, what you mean the number inside? What you mean? So, can you can you tell the numbers instead of saying? Okay. So we have 98. That is original number, right?
Mm-hmm.
We want to simplify squares of 98. What we said here, we want to break down 98 if possible. Sometimes it's not possible, but if it is possible, break it down as a product of two numbers, and we want one of them to be a perfect square. Now, do we know what are the perfect squares? For instance, between 0 and 100, the perfect square are 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, right?
Mm-hmm.
You see, we want, every time we break down a number, we want to see one of them, right? If possible. If not possible, then we can do nothing. Now, 98, somebody told me, happens to be 49 times 2, right?
Right.
So now, you see, 98 49 times 2. So now we can bring the 49 out. But when we bring it out, it is squares of 49. How much is that? It's 7, you see?
Yes.
It becomes 7. Now the 2, there is nothing we can do with the 2. We're going to leave it inside the square root. Anyone that is a perfect square, we can get them out. Anyone that is not a perfect square, they're going to they will stay inside the square root, right?
Yeah.
So that is how we do. If possible, that is how we simplify. So now 98 happens to be 14 times 7.
Mm.
Is that way to break down 98? Is that way helpful?
No.
It is not helpful, right? Because none of them is a perfect square, right?
Right.
Okay. So, okay, I let you like a couple of minutes. Try to do these three. I have squares of 50, squares of 200, and the squares of I mean, 7 times the square root of 32, okay? Try to do this, please. All right. I'm gonna let everybody try to do it, okay? So I don't rush. I want everybody to try to simplify these. And matter of fact, I'm gonna add one more here, negative 13 square root of all right, so now you have 4 of them. Hello, Haley. The class will be done in Teams. You can see the link in your email, or you can see the link in Brightspace. Yeah, thank you. Mm-hmm. So the only thing that was more convenient with Zoom was we can schedule the same meeting for all our classes. But in Teams, as you can see, there is a link for Tuesday and there is another link for Thursday. Okay, so there was no other way around it. Okay, we have to have like 2 links if you want to do the recurring meetings. They have to be different, okay? So the link you use today is not the same you're gonna use Thursday, all right? Okay, so one more minute. Please, everybody, try to do that. You see, try to do that because the same stuff will be in the quiz, will be in the test, etc. The same questions. All right. Okay, let's start. Okay, can somebody go ahead and solve for us the first one, the squares of 50? Can somebody go ahead and tell me what they did?
I can.
Please go ahead.
It would be the 50 would be broke down into 2 times 25.
Thank you very much. 2 and 25, right? So squares of 25 and 2, exactly. Yeah. What next then?
And then the square root of 25 is 5.
Exactly.
So in front,
Yep.
and then it would be 5, and then the 2.
Square root of 2. Right? If I see that, the 25 gets out, but when the 25 gets out, it becomes a 5, right? It doesn't stay as 25 because we're applying the square root. Now, a very, very common mistake, very common mistake is some students can write this, you see. That is a very common mistake. When you apply the square root of 25, it is 5, right? If you put another square root on top of that, then you are duplicating. You cannot duplicate the square root. You cannot apply it twice, okay? So please avoid that mistake, okay? Thank you very much. Somebody else, can you tell us this for square root of 200? How you break it down?
I can.
Yeah, go ahead.
102.
Thank you. 102. Square root of 100 times 2, right?
Yes, and
Okay.
then square root of 100 is 10, so it'll be 10, 2.
Exactly, 10 square root of 2. Thank you very much. That is absolutely correct, right? Because 200, actually 200 is like, very noticeable is 100 times 2, okay? Thank you. Okay, the next one now, the only difference with the next one, it has a 7 in front of it. But does it change the technique? The technique will be still the same. We're just gonna be mindful that we have 7 in front, right? Okay, somebody, please. What you did with this one?
Can I go?
Go ahead, please.
I don't know if this is right, but I'll try. So,
Yeah, go.
so I guess what you would first do is you would remember that 7 times 7 is a perfect square of 49. And
Yes,
and then I multiplied 49 by 32, but I don't think that's right.
Yeah, that you see that at the most, it is very complicated, because somebody who was out, you try to get them in. It should be the other way around. You see, 7 is already out, right? So it's like making it way harder, mathematically talking. It's like making it way harder if you try to bring 7 inside the square root, right? That is not the way we want to do it. We want to do the other way around. This is a 32. We want to manage to get some people out, not in. So the 7 will be left there for the 7 will be left outside. All what you're going to do is to work on the 32. How to break down 32? What numbers you're going to use?
25. No.
You need. Yeah, go ahead. You said 16, right? I heard 16. 16 and what?
And 2.
16 and 2, exactly. You see?
Because that's the 4 is square root of 16.
Yes. So, and then it's going to be 7. You see, for now, I leave the 7, tranquil. I even don't touch it. Squares of 16 times 2. You see? Now the 16 gets out. When the 16 gets out, it becomes what number?
4.
It becomes a 4. But then who was there before the 4?
The 7.
The 7 was there before the 4. So I don't forget the 7. So now I have to multiply the 7 and the 4. What I get?
28.
28, exactly. Good. This way is way easier than the way you're trying to put the 7 in. If you try to put the 7 in, you can do it, but I don't advise that, because when you get the 7 inside, it becomes a 49. Exactly what you told me was correct. And then you have to multiply 39 by 32, then it is way harder, right? Okay. So that is the simplest way to do it. Okay, thank you very much. How about the last one? Somebody. the square root of 12. How are you going to break it down?
I can do it.
Yeah, go ahead, please.
It is 4 and 3.
4 and 3, thank you. You see, it'll be negative 13, square root of 4 times 3. All right, so what next?
The 4 is broke down to 2 times 2.
The 4 is 2 times 2, so which means the square root of 4 is how much then?
2.
It's 2, you see? So this becomes, you see, some people do that. I think this is a sub-step that is not really necessary, okay? That sub-step right here, we know square root of 4 is 2, right? So when you write it this way, it becomes more clear, but you know, sometimes you just say it's 2. It's negative 13 times 2, and then root of 3, right? And then negative 13 times 2 is negative 20?
26.
Root of 3. Thank you very much. All right. Now, if somebody has a question, before we move on to the next set of problems, please ask them. You see, we need that interaction. We need somebody to tell, because in the test, clearly, some students did not understand clearly some topics, right? So how I know if somebody doesn't come to my office hours or if they don't say it in classroom? You see, it's very hard to know. You only see that when the test comes out, but then it's late because now you have the test is in, right? The grades are in. So that is why, you know, we encourage you really to voice, you know, if you don't understand, to voice it out. And then if really you don't, you know, if you need help, to come to the office hours. All right. So now we have another property, which is also a very, very important property, right? Which says square root of a squared actually is a. So basically it's a when a, if a is non-negative, if a is non-negative, then square root of a squared is a. Look, as if what? As if square root and square cancel each other, which is expected, right? Do we expect that? We expect square root and square to cancel each other because they are inverse actions. When square somebody, or you take the square root, you are doing two things that are inverse each other, right? You see, when square 3, you get 9, right? When you do squares of 9, you get 3, right? You see? So what one will do, the other one will undo it, okay? That is expected. But the A has to be positive, you know. Okay, this is O83. We don't want to enter into the details. But this, they cancel each other if the A is non-negative, right? Okay, so for instance, when you say square root of 6 squared, why it is 6? What is 6 squared? How much is 6 squared?
36.
36. What is the square of 36?
6.
Is 6. You see, instead of passing through that step, is it easy to do this? These two cancel out, and then what we get? We get 6, right? That is very, 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 very interesting. So square root, you see, if somebody asks you to do this, square root of 1,567 square, what you tell them? Do you get your calculator out? Or what you say? What's the answer here?
1,567.
Exactly. You don't get your calculator out because these two cancel each other. You got 1,567. Okay? All right. So you see, if x is positive, so we have square root of x squared is just x. You see, they just cancel each other. That's it, right? Now, okay, now from this, can somebody give me a hint how to simplify this one? square root of x to the fourth? What do you think? According to the rule we just stated, how much is going to be square root of x to the fourth then? Can we write, okay, let me phrase it this way. Can we write x to the fourth? Can we write x to the fourth as a square of somebody? X to the fourth is a square of what?
X to this
Go ahead, you are very close. X to the what power?
second.
Thank you. Everybody understand that? Do you remember the rules about exponents? When you compound them, what is 2 times 2?
4.
It's 4, right? So x to the fourth is a square of x squared. So basically, if I write this as, this is a square of x squared, what's going to happen to the outside square? What's going to happen to the outside square? To the blue square, what's going to happen to it?
It's just going to be x squared.
Exactly. This blue square will cancel with just square root, right? Your answer will be x squared. See that? Okay. From the same token, what do you think is going to be square root of x to the 6th power? X to the 6th power can be written as the square of what power? X what power?
To the third.
X to the 3rd. Everybody understand that?
Yeah.
Do you recall the rules about exponents, right? When you see something inside the radical, x to the 3rd all to the square power, what is your new power? Is 2 times 3, right? Which is 6, okay? That'll be x to the 6th. So that is, so what's going to happen to the black 2? The black square, what's going to happen to it? It's gonna?
It cancels out.
It's cancelled out with the square root, right? This 2 and the square is cancelled out. How much remains?
X to the third.
X to the 3rd. Okay, now let's see if you have any link between the initial exponent and the final exponent. You see? The final exponent appears to be the initial one divided by how much?
By 2.
By 2, exactly. That is the pattern. The final exponent appears to be the initial one divided by 2. This is what square root does. Square root divides even powers by 2. Okay? Square root divides any even exponents by 2. Do you agree with that? So square root, let me write it down. Square root actually divides even exponents by 2. So because of that, when somebody asks you to do square root of x to the 14th, right? Do you need to do all the work, or what's going to be your answer? What's going to be your answer? Because of the sentence I just wrote, right? What's going to be the answer then? X to what power?
X to the 7th power.
X to the 7th power. Because how much is 14 divided by 2?
7.
7. Everybody see that? Everybody? So go ahead, do this. What is the square root of x to the 18, square root of x to the 24, right? Square root of x to the 10, y to the 16, and z to the 2nd. Okay, go ahead, everybody. Write the answer. Everybody, write the answer. I really want everybody to write an answer they think is the right answer, and then we're going to see if it is correct or not. Okay. So can you tell me how much is the square root of x to the 18th?
Yes, it's x to the 9th.
Thank you very much. And 9 comes from 18 divided by 2. Thank you. X to the 21st?
X to the 12th.
X to the 12th, thank you. 12 comes from 24 divided by 2. Okay? And then the last one, what's going to be?
I think it's x to the 5th,
Uh-huh.
y to the 8th, and then is it just z?
Yes, z to the 1 power or just z. Thank you.
It's z. Okay.
Yes. You see, everybody, square root will divide your even exponent by 2. Okay, this is what square root does. So now, okay, can somebody tell me what's going to be the issue then? Can somebody tell me what's going to be our next case before we try to do it?
We're going to be doing uneven numbers.
Exactly. Exactly. When our next case will be when the exponent is not even, right? That's going to be the next case. You see, if it is even, it's like, very simple. Okay, just divide it by 2. But if it is not even, then we need to see some examples. Look, square root of x cubed, right? First of all, if your exponent is odd, your final answer will always have a square root, always. There's no way around that, right? So how are we going to say it? So for instance, square root of x cubed. We have to do the same stuff we did with the numbers right here. We have to do the same stuff we did with the numbers. We have to break down x cubed as 2 exponents, right? X cubed with an even exponent and an odd exponent, right? All of you agree with me that x cubed can be written as x squared times x. Everybody agree with me?
Yes.
Right? Because what is 1 plus 2?
3.
Is 3, right? This is every time your exponent is odd, this is how you're going to break it down, right? The next even exponent and then 1x left, right? Because any odd exponent can be broke down into an even number plus 1, right? Any odd number can be broke down into an even number plus 1. You see, 17 is what? 17 is 16 plus 1, right? 21 is what? 20 and 1, right? 49 is what? Is 48 and 1, right? So you have to break it down this way. The x squared, we just dealt with it, right? What's going to happen to the square? We're going to divide it by 2, right? It's going to be what? X what power? X to the 1 power and then square of x. You see? Everybody see that? This one come from what? This one come from 2 divided by 2, right? And then you're going to always have squares left right there. So if I do this, square root of x to the 7th, right? Okay, How am I gonna break it down?
X to the third times X to the second.
X to the third times X to the second. Yeah, I mean, you mean that's gonna be your final answer? We
No.
want to do the step first. How are you gonna break down X to the seventh? I think it's better to break it down X to the 6 and 1, right? Times X.
All
Okay.
right.
Always the next even number to 7, I mean the even number before 7, and then times X. Everybody understand that that way to break it down? Everybody gets this? So now what's going to happen to the 6, power 6? This one gets out. When this one gets out, the power 6 become what power?
X to the third.
30.
Exactly, it becomes X to the third. Everybody that gets out should be divided by 2. Every power that gets out should be divided by 2. And then the other one, there is nothing to do with it. So we just X to the 1 power, right? Okay. So now look now. This I want basically to see if there is a shortcut to figure out the final answer. When you divide 7 by 2, not using a calculator, right? How many times 2 goes into 7? For those who know division very well, how many times 2 goes into 7?
3.
3 times. You see 3 right here. You see? This 3 is how many times 2 goes into 7. So when you divide 7 by 2, you get 3 times, right? That 3 is the one, that 3 times is the one we have here. What is the remainder? How much remains? 2 times 3 is 6, 7 minus 6 is 1, right? The remainder one is this right here. Okay? You see, you can apply that shortcut if you want to, okay? You can apply that shortcut if you are good with division, okay? If you're not good with division this much, you can go ahead and do the steps that we just did. Okay, let's do one more. Let's do like square root of 23, x to the 23. Okay, let's try to do the shortcut first. I see if some people will pull it off. How many times 2 goes into 23?
11.
11 times, right? That 11 will be the power outside. How much remains?
1.
The 1 will be the power inside. You see? If I see that, isn't it a good shortcut there? That is a shortcut. If you don't want to do shortcut, how you break it down? Without shortcut, you're going to break it down as x to the 22 times x, right? Now the x to the 22 goes out, becomes x to the 11, because 22 divided by 2 is 11, right? As a root of x, okay? So basically, when your power is odd, there will be always an exponent left. There will be always a square root left, square root of x left, always. Now, though, the exponent outside is actually the quotient of the division by 2, okay? All right, so can you do this one, some square root of and then all right, go ahead, please, everybody. All right. So, what do you think? Square root of x to the 17th. What's going to be the power outside for the x?
X to the 8th,
Thank you. And then,
and then an X under the square root.
yep, everybody agrees with that. X to the 8th. And then it's going to be squares of x. Why? Because this one could be broke down into x to the 16th times x to the 1 power, right? The 16 goes out and will be divided by 2, so it becomes an 8 outside, and you always have squares of x left, right? Okay, a to the squares of a to the 9 power. What's going to be the power of a outside?
4.
4, thank you. And then squares of a left again, because this I view it as a to the 8 times a, right? The a outside, 8 divided by 2 becomes a 4, and then we have a to the 1 power, all right? Squares of y to the 25th, right? What's going to be the power of y outside?
12.
Somebody. 12, thank you. 12, because again, the even number next to 25 is 24. 24 divided by 2 is 12. And then you have squares of y, right? Okay, and then these two. What's going to be the power of a?
A to the 10th.
A to the 10th. Will we have any a's left inside the square root? Will we have that?
No.
No. No a will be left inside the square root, right? And then what's going to be the power of b outside?
To the 6th.
B to the 6th, right? Thank you. 12 divided by 2 is 6. And then square root of what?
B.
B. Thank you very much, right? So you see, these are, okay, so now let me see if we can go ahead and the textbook, a couple of problems from this section. Okay.
Is the screen frozen?
No, I thought mine was too, but I don't think it is because I can move things around.
Like, is his though? Professor All, where'd you go? We can't hear you or see what you're doing.
I think he must have went away.
Yeah, he just left. I think he realized there's no help in it.
Oh, sorry, my grandchild.
Uh,
Oh, hi. Oh.
She's doing online school too, so that's why I'm moving. Go over there to your school. I wonder, should we wait or go out and come back in?
I was thinking he would come back
Yeah.
because he probably realized he was frozen.
well, it's still recording, so I think he can come back.
Yeah. That's a good point. Don't know.
No, Ripley, get up there and do your class. Sorry, let me mute myself.
We should probably all write our names just in case he doesn't come back.
Yeah, I was trying to see, where do we write our names on this one? Oh, here's the chat.
Yeah. Oh, welcome back. You're muted, Professor.
You know, that sucks, you know. I really didn't know that, you know, the whole thing was shut down, you know. Something happened to the, maybe to the you know, internet or something like that. Yeah, I'm sorry about that.
So where do we put our name on this one? Because of this, when I click on the chat, it says chat and channel meeting is only available to team members.
Yeah. So for the teams, I think what is good about teams is I think the recordings, everything will be there.
Okay.
So now I have to ask you, you know, how to. I think if you go there, you're gonna see the recordings, etc., etc. So I have to. So let me see. Desk, Windows. Okay, window. That is the window we were sharing, right? Okay. So I really have no idea what happens. So it shut down like that. Okay. So did you get a chance to do these two or not? Not even get a chance.
No, we weren't able to see that.
Okay. So I'm gonna let you like a couple of minutes try to work on these problems. So first one, you have to take care of 32, take care of X, take care of Y, take care of Z, right? So some people will be completely out. Some people will be left. We'll have something left in the square root. So basically, your final answer will be square root. Some people will be here, outside, and some people are going to be inside, right? All right. Okay. Can somebody walk us through the steps for the first one? Please.
I can try. I don't know if I have it right though.
Yeah, go ahead.
All right. 32, I would break down to 16 and 2.
That is absolutely right. Okay.
So, and the square root of 16 is 4.
Yep.
So 4 would go on the outside and 2 would stay on the inside.
Yep.
And then x would stay on the inside.
Yep. There is nothing to do with x. Thank you very much. Yep.
And then y would, 1y would come on the outside.
Uh-huh.
And 1y would go on the inside. I wasn't sure about that.
Okay, so let's stop for 1 second. What is the power you see in for the y?
2.
That is an even power, right?
Okay.
Every time the power is even, there will be no residue.
Okay.
Because 2 divided by 2 is how much?
1.
Is 1. That's it. You see, there is no remainder, so that means there will be no y inside, right?
Okay. Okay. And then z, there would be 1 z on the outside.
Yeah.
And 1 z on the inside.
Absolutely correct. Because again, z is odd. I mean, the 3 is odd. So when you divide by 3 by 2, you have a remainder, and that is the remainder which is inside. See, and how many times 2 goes into 3? 1 time, right? That is the one which is outside. Okay? And that's going to be the final answer.
Okay.
Everybody see that? So it's going to be 4 y z and then squares of 2xz. All right. How about the next one? We're going to try to do the same thing. The 28 will be broke down into what numbers?
4 and 7.
4 and 7. Thank you. That is absolutely right. Okay, so the 4 goes out. It becomes what number?
The 4 would stay in the radical and become 2. The 7 would go out and be multiplied by the -5.
Now look, it's all the way. I think it's always around. The 7, which is not a perfect square, will be inside the square root.
Oh,
Definitely. The other way around. The 4 walks out from the square root. It becomes what number? Becomes a 2, right?
Yes.
You see, the 4 walks out and it becomes a 2, right? So, and 2, but there was a -5 here already. So it's going to be -5 times 2, okay? When you break down the numbers, anyone that is not a perfect square will be inside the square root. That number will never move, okay? The number that is a perfect square will go out and it become an, and becomes another number, okay? So now x cubed. How much will be outside for x cubed? What power will be outside?
The same as the z above. 1 will be on the outside and 1 on the inside.
Thank you very much. How about y to the 4th?
I believe that's a perfect square. So on the outside you would have y squared.
Do I have any y inside?
No, there's not actually.
No y inside. Thank you.
Yeah.
No y inside whatsoever because y has an even exponent, right? So now my very, very final answer is when I multiply -5 by 2, I get -10 x y squared root of 7x, okay? Okay, everybody, so do you have any questions about this before we move to the next examples? No? All right. So what's going to be our next stuff? Our next stuff is actually this. You see, when you multiply a square root by itself, when you say squares of a squared, that is actually also a. it does not matter which one comes first. What we said before is squares of a squared is a. Now we are saying squares of a all squared is also a. Okay. Provided that if a is non-negative, right? So it's the same thing. When you multiply squares by itself, what we say here is when you multiply the square root by itself, it's just a. Okay. When you multiply squares by itself, the two squares cancel out. It becomes a. Okay. You see, what we say here is what is the squares of 7 times the squares of 7? What you going to say? It's just
7.
7, right? You don't need to do the math. If you do the math, what's going to be? What's the squares of 7 times squares of 7? It's squares of 7 times 7 is squares of 49, which is 7. You see, you don't need to do that step. You just go ahead and write the final step. What's going to be squares of 13 times squares of 13? What you say?
13.
13.
That's 13, right? We don't need to do the math. When you multiply squares by itself, they cancel each other, right? You get the same number inside. Okay, so now if you have this, if I have square root of, 5x times squares of 5x, what I say?
5x.
5x. You don't need to do the math, please. Don't try to do the math. If you try to do the math, then you are inviting mistakes. Okay? Don't try to do the math. As long as they are exactly the same. If they are exactly the same under the radical, then it's just the same number over there, right? If we say square root of 19ab times square root of 19ab, do we see exactly the same thing inside the radical? Do we see exactly the same thing?
Yes.
So what's going to be my answer then?
19ab.
19ab, right? Okay, I don't need to do the the math inside. If I do the math inside, I will still get the same answer. Okay. Okay, that is what we could have said from square root. Okay. All right. So after square root, of course, we're gonna see some other exponents, right? So let me check one thing with the. So we have another problem with my open math. I need to check one thing with my open math. See if. Okay, 3.1 and see what do you have in 3.1. Okay, so they talk about division. So we're going to talk about division a little bit, okay? Not a lot. So we said we can split division, multiplications in the same way we can split division. If you have squares of A divided by B, if both of them are positive, you can split. You can say squares of A divided by squares of B, okay? The same way with the multiplication, you can do the same with the division, okay? For instance, if somebody asks you to simplify square root of 80 divided by square root of 5, right? Simplify that. Okay. For instance, do we know exactly how much is square root of 80? Is 80 a perfect square?
No.
It is not. Is 5 a perfect square?
No.
It is not. But there is something there, we can group them. If we apply this rule, we can group them under the same umbrella, right? Hoping that 80 divided by 5 will be a perfect square. How much is 80 divided by 5? Is it 16, right? So you see it's 4, right? So same thing, can you do squares of 32 divided by square root of 2? Go ahead. Can we simplify this?
I got the answer in like 2 seconds.
Oh yeah,
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 it's the same thing.
it's the same thing, is it?
yeah, I like this trick.
Okay, so how much you got?
4.
You got 4, all right. You see, it was a lack of imagination, you know, on my behalf, right? You see, I should have gave you something at least that give you, you know, a different answer. You see, so it's because of 32 divided by 2, which is root of 16, which is 4. All right, but in the test, of course, we insist more on the multiplication part, right? The division, we do it, but we insist more on the multiplication part, which is what we did so all over here. Okay, so all right, so please look. For instance, you go to the share. Right, so entire screen. Okay, when you go to my open math right here, you see this is 3.1. Okay, how you know you are ready for the test? If you know by yourself how to do everything in here, okay, by yourself. This is how I know for this topic I'm ready for the test. And how you know you even more ready than that if you know how to do all these right here by yourself, okay? You see, we have a lot of stuff to practice, you know. You have the textbook, you have my open math, etc., etc. You can practice all these right here, okay? And then if you need more explanation, then you can come to my office, right? My office hours, you know. The office hours for now, we're gonna leave them with Zoom, right? For, you know, the Zoom link, because, you know, the office hours, it does not bother me to restart the meeting every 40 minutes, right? For the office hours. So we're gonna leave them in Zoom. But for this class, we're gonna go in Teams, okay? All right. You know, that was the first stuff. So now the next section is higher roots, you know, cube root, 4th root, 7th root, etc., etc. Okay, so that is the next section right here. The same way we define square root, we're going to define cube root, we're going to define 4th root, 5th root, etc., etc., nth root. So this is 3.2 higher roots. For instance, we say 2 cubed is equal to 8, right? And because of that, we say cube root of 8 is equal to 2. Okay? So for any other radical, you have to put the index. This is the index right here. For any other radical, you have to put the index. This means this reads cube root of 8. Cube root of 8 is 2. Okay? All right? So for instance, we say 3 to the 4th power is 3 times 3 times 3, 4 times is 81. What you gonna say then? If you want to write the radical notation, you're gonna say what? What radical now is gonna involve? Cube root? What do you think? Or square root? What do you think? What radical? If we say 3 to the 4th power is 81, what radical is going to involve?
Would it be square
Fourth
root to the
radical.
second?
4th root, right? Because this is power 4 is going to involve the 4th root, right? 4th root of 81 is equal to 3, okay? 4th root of 81 is equal to 3. So when you say 2 to the 5th is equal to 32, right? I did the math in my head. So what radical is going to involve? This is fourth root of 81 is 3. So here is going to involve what radical? What root?
2.
It's going to involve
Fifth root.
fifth root. Exactly. Thank you. Fifth root of 32 is equal to 2, right? Etc. etc. These are, these are the higher roots. Of course, in O83, which one are you going to see the most? I think at most we're going to ask you on cube root. Okay, at the most. Okay. There's no incentive to ask you about fifth root or seventh root, or there's no mathematical incentive to that. Okay, so we're going to ask you more like 90% square root and 10% maybe cube root. That's it. Okay, so now when I say this, when I say a to the n is equal b, how are you going to write? If you want to mimic what you just wrote, what's going to be the radical notation of this statement?
The nth root.
Nth root of who?
Of b.
Of b is equal to what?
Equal to a.
A. Thank you very much. You see, this means the nth root of b is a. All right, the nth root of b is a. Okay, so again, do we go ahead and just no, we don't. For instance, we say 2 to the 10 power is 1024, right? So we say 10th root of 1024 is equal to 2, right? So we say -3 to the fourth power, I mean -3 to the -3 to the third power is -27, right? So we say cube root of -27 is -3. You see here, this example shows cube root does not care about being positive or being negative. Cube root does not care. Square root does care, right? Square root does care. If I have my calculator right here, let me see. Okay, so for instance, I have square root, I have cube root. Okay, I have them. No, you have square root. Okay, I have square root. I don't have cube root, So square root does care about negative number. If I say 4, -4, and then I put square root, you see invalid input. But cube root does not care about that, okay? Cube root does not care about being positive, being negative. All right. So, and you have the same property. You absolutely have the same property. It says when you multiply 2 nth root, you can bring them together, right? Or you divide, same thing. When you divide 2 nth root, you can actually put them together, okay? These are the same properties, just like with the cube root, I mean with the square root. For instance, if we say cube root of 2 multiplied by cube root of 32, right? Do we know exactly for sure? Do we know exactly how much each one of them is? Do we know exactly how much is cube root of 2? Is that a perfect number? I mean, perfect cube?
Yes.
Is 2 a perfect cube? What are the perfect cubes between 1 and 100? 1 cubed is 1. 2 cubed is 8. 3 cubes is 27. 4 cubed is 64. 5 cubed is 125. You see, these are the perfect cubes right here. Between 1 and 100, right? Is 2 among them?
No.
2 is not a perfect cube. Is 32 a perfect cube?
No.
It's not. But what this rule allows us to do, this rule right here, the same thing we did with the square root. What can we do?
You can break it down.
We can put them together, right? Inside, you can say 2 times what?
2
32,
times
right?
32.
And 2 times 32 happens to be what number?
64.
64, which is exactly a perfect cube, right?
Yes.
And how much is cube root of 64?
8. No, 4. Sorry.
4, okay. You see, when you say 8, you thought about square root, right?
Yeah.
It is 4, because 4 cubed is 64, okay? So we're gonna continue on that Thursday. You know, we're gonna stop here today. You know, meanwhile, I'm gonna see how you guys can access the recording. You see, I'm gonna see if I need to put it on Brightspace like with the Zoom sessions, or you have access to it with Teams. I think you will have access to it with Teams, or maybe I will have to post it on Brightspace. You know, I'm gonna ask around how to do that. This is like my first time, you know, using the Teams, you know, as a host. Okay, I went to Teams meeting, but as just a participant. So this is my first time as a host. All right.
My history teacher, he posts his Teams recordings to Brightspace.
Okay,
But-
so there, okay, which means I will have the link, and when I have the link, I will post it on Brightspace. Thank you for the information.
No problem.
All right, everybody. And you see, please, everybody, after the test number 1, like I said, after test number 1, please, if you need help, you have to be proactive. You have to come to my office hours. I hold office hours, and if you come to my office hours, 20 minutes, 30 minutes, you don't, you know, you have a couple of questions, you know, I can, you know, it does help, okay? It really does help, all right? Okay, thank you, everybody. You see, the attendance for the teams, I can download the attendance, okay? So you don't need to type your name, you know.
Okay,
Which is good about Teams. You can download the attendance, you know.
great.
All right. Thank you
All right,
very much,
thank you.
everybody. Thank
Thank
you.
you.
See you Thursday.
Bye.
Have a nice day.
Thank you.